join, I'll be dropping the link on the chat box. You now have access to web development opportunities, jobs, internship, and part-time roles. So do well to apply. And if you are having any issue applying, please, you can reach out to us on Discord. We will do well to recommend you to help you out. Thank you all, and wishing you all an awesome class. Thank you so much. Over to you, Mr. Samuel.
Thank you. So I'll start my presentation now. Hope everyone can see my screen.
Yeah, sure. We can.
Okay, so today we're talking about smart contract. I think over the last couple of days, we're talking about the Ethereum blockchain, and the fact that the Ethereum blockchain is different from every other blockchain, especially Bitcoin, and that the fact that Bitcoin is a blockchain solely designed for peer-to-peer financial transaction, like peer-to-peer Bitcoin transactions. That's the sole purpose of the block of the Bitcoin blockchain, for example. And that Ethereum is designed for decentralized processing. Like, yes, you can transfer you can make financial transactions, but financial transactions is just a side effect of the main purpose of the Ethereum blockchain. So, so today we'll be talking about that special, unique feature of the Ethereum blockchain, which I believe is which is smart contracts. Okay, so a smart contract is technically it's in computer program. I don't use the word small. It's it's a computer program that runs on the Ethereum blockchain. And why like why do we need this smart contract? What are the use? Like, what do we use? What do we use them for? So very simple answer is smart contracts enable complex transactions, because in life financial transactions are way more complex than sending money from Mr. A to Mr. B, right? Financial transactions are complex. Some financial transactions need authorization. Some need maturity time, right? You need maybe then some are conditional, right? So the transaction has conditions that have to be met before it is finalized and stuff like that. So in the real world, transactions, be it business transactions or financial transactions, are way more complex than sending money from Mr. A to Mr. B. So, for example, a very complex transaction is a post-dated check, right? I hope that's the word for it. When you write a check that is to be cashed at a specific date. So that's an example of a complex transaction that you probably can't do on the Bitcoin blockchain, for example. So that's why Ethereum exists. So Ethereum exists to fill that void, the void I would say Bitcoin blockchain created. Yes, you could perform transactions, but very simple peer-to-peer movement of Bitcoin from person A to person B. So, so what are the key points? So I start something that is to right away. Okay, so that's the point there is it's a program running on a decentralized network, meaning smart contracts are decentralized in themselves because they run on a network that is decentralized, right? So meaning any program that is running on Ethereum blockchain is decentralized and not be shut down. Like I explained the meaning of decentralization. Like the meaning, yes, the literal meaning of decentralization is something that is not concentrated or centralized in one specific location or processing area. It's something that is distributed. It's everywhere, right? At the working and acting with Google. So yeah, so these smart contracts to enjoy this property of the Ethereum blockchain. So meaning if you want, and again, one of the advantages of decentralization is censorship resistance. The censorship resistance is you cannot ban the Ethereum blockchain, for example, right? And what that now means in the context of smart contracts is that you can't also ban a program that is running on the Ethereum blockchain. Yeah, so whatever the program does is you can't ban it. People will always have access to it. You can make it illegal, right? Yes, you can make it illegal, but you can't stop people accessing it. That's one of the benefits of decentralization and Ethereum blockchains. So yes, then the second point is smart contracts are a smart contract is an Ethereum account. So meaning a smart contract is literally like an individual. It's just like an end. So you have two type of accounts on Ethereum. You have the end user account, and you have the Ethereum, and you have the smart contract, right? So your smart contract has an address, just like someone's wallet. So anybody participate. So I spoke about clients and validators on the Ethereum blockchain, and I said clients were literally people like you and me, right? Who would perform transactions on the blockchain. And for us to perform those transactions, we need an address. And then we then spoke about wallets in our last class. And I spoke about wallets and how you get a wallet, how wallet addresses are generated, and how wallets enable you to perform secure and encrypted transactions on the blockchain. And yes, with regards to wallets, I think there's a point I missed out that I would want to say now. So I spoke about elliptic curve multiplication, and so I want to stress one fact that I don't know if I made this point very clear. The elliptic curve multiplication is a one-way multiplication. So because I did show, so let me even back the slide just for a few minutes, just so that yes. So I did show G. So I said G was the generator point, and the generator point was a publicly known address that everyone knows, right? YK is your randomly generated private key. So if you multiply K and G, you get your wallet address, right? So someone might ask, what if you divide big K, right, over G? Once you get your small k, which is your private key, the answer is no, because your elliptic curve multiplication is a one-way multiplication, meaning anything you multiply with elliptic curve multiplication, you can't divide it to get the other platform. So that's the property of elliptic curve multiplication that allows us to have this public and private key. So I just want to bring. So back to smart contracts. So yes, so end users have their wallet addresses. Smart contracts also have their wallet addresses, and that also means smart contracts could also have money, right? And could also have balance. So the smart contract could literally hold money too, right? Just like a human being. So this is a very important feature of smart contract that I would show you how it comes to play and how it enables very complex transactions. So then yes, the second point used to enforce agreements, and code is law. So yes, smart contracts allow you kind of like write applications that um, can be used to enforce an agreement. So in real life, right, when you enter into a business agreement with someone, you need two parties to sign a contract, and there must be a legal representative as part of the um, uh, signatories for that contract to make it legally binding, right? I think there are some contracts that you don't even need a legal representative. I think all you need is written down agreement. I hope my secondary school business studies. I don't know if you let me I digress. So yeah, in the real world there are contracts that people sign and that are enforceable by the courts, right? But in decentralized land, right, on a blockchain, um, because the parties who are participating in a transaction blockchain are anonymous, right? You don't know them. So we need a way to kind of like ensure that okay, everybody respects an agreement. So one way to enable that is through smart contracts. So smart contracts allows us enforce agreements, right? When we write a smart contract and any party who binds the agreement in that smart contract is their addresses, right, would now be under the purview of the smart contract itself. So, for example, let's say there's a smart contract that allows you to pay someone after the person has shown proof of work, right? Proof of work in this context now is proof that someone did a job. I don't want to be confused with proof of work in Bitcoin. So let's say you have a smart contract and someone has to do a job for you, and the person wants to be sure that you will pay him, right, when he's done with the job. And you want to be sure that the person will do the job that assigned him to do. So one way to kind of like implement this kind of agreement with blockchain, right, is to write a smart contract. You write a smart contract where the input smart contract will hold and the money for the payments can only be released to the address of the person who's going to get the job done when the person tenders a proof that he has done the job. Then the proof of work done can be something both of you agree on. It can be maybe a link to a document that contains, let's say, 10,000 words, and anyway, this is something that both of you would have to sit down and agree. You have to agree on what would be a acceptable proof, right? That can be digitally confirmed. So both of you agree, and you write that. You build that through the contract. You deploy the contract. You deploy the contract to the payments, right? And when the person is done with the job, and again, you also specify that the money in this contract will only go to the address of this person doing the job. Then you deploy the contract. Then when the person is done with the job, the person sends a transaction to the smart contract. Remember, a smart contract has and a smart contract is just think of the smart contract as an individual that is put on the blockchain, an unbiased individual that is put on the blockchain to check transactions. Just imagine it that way, at least for now. So you can then, because the smart contract has an address, you can interact with it, right? So you can then send your proof of work done to the smart contract. Then the logic for verifying the proof of work is also in the smart contract. The smart contract can now, one, check that the address that is sending the proof of work with is the one that was designed to receive the funds, right, after the proof of work has been verified. Then it verifies the proof of work, then releases your money to you, right? So both parties there's no need for any lawyer or whatever. The code becomes law, right? So that's one of the very beautiful things as smart contracts. So the reason why I use this example is to buttress the fact, to just um, emphasize the fact, the naming of this feature, smart contracts, right? So that this example kind of like captures the essence to a very large extent of what smart contract can do. So then my third point is smart contract could be non-upgradable. So this is a very, very critical feature. There are some smart contracts that are upgradable, right? But a smart contract not being upgradable is a very key feature because going back to the third, um, okay, sorry, this is the fourth point. Going back to the third point, where I said code is law. When a code is law, right, there are situations where you don't want that law to be updatable because if someone updates the code behind your back, right, the person can modify the agreement, and before you know it, it was not what you agreed on that the smart contract is now executing. So there are some situations where you have to ensure that your that the whatever smart contract you're interacting with or whatever agreement you are getting into via smart contract with blockchain is done with a non-upgradable smart contract. So that's very critical. But of course, there are situations where you need upgradable smart contract. There are some situations where things can change, right? Situations can change. Life is dynamic, and you also want a smart contract to be able to change when those situations occur. So in that case, you also have an upgradable smart contract that allows you use that kind of smart contract. So then my final point is solidity. So smart contracts have to be written in a language, right? Just like every other programming language, just like every other software. And the programming language is solidity. That's the um, primary language for writing smart contracts. Yes, there are some new, there are some advancements, or I would say some innovation where people are beginning to write smart contracts with other languages, right? But it will be transferred back to Solidity, or rather by code directly, right? But that kind of like they are still untested technology, so I won't go more into that. But Solidity is your primary means of writing smart contracts with blockchain. So yeah. So any question? Just maybe I'll try and so I'll pull up a simple example while I wait for questions. Okay, I'll example what smart contracts. I won't go too much into detail, but just something small to just say uh, for any if there is need for more technical, maybe hands-on, uh, multiple hands-on maybe presentation or exercise. Um, Maybe we could communicate that via the Discord channel. So, but I'll try not to go too much into technical details just to save time of the 1 hour invitation. Um, so, okay, so so this is so uh, this is smart contract, right? So this is smart contract, and it's written in Solidity. This is a big version of Solidity that this smart contract is designed of Solidity that this smart contract will work with. And then these are dependencies like other libraries, other utilities or code that people have written that I could want to use in our smart contract, right? Then this smart contract is in this specific case is upgradable, right? It's ownable and it's upgradable. So um, anybody who wants to interact with this smart contract would one, there's a way you can verify this any smart contract you're interacting with. So this particular one is upgradable, and that's because of the way your operation it does. So the operation it does is one where you might need to upgrade it in the future if you need. So yeah, so this is just an example. Doesn't do much. Um, but one thing I want to maybe highlight here is this: when you're interacting with a smart contract, you could send smart contract money, right? You could send money to a smart contract because remember, a smart contract has an address. So because a smart contract has an address, um, you could also um, send money to it, and you can also receive money. Uh, okay, so collect some use Rust. Yes, exactly, exactly. So Rust is one of the languages that are used. There's some blockchains that use Rust, right? But for Ethereum, it's Solidity. There's some blockchains that use Rust to write their smart contracts, and I think I think I have to verify. I think there are also um, some there's some libraries or frameworks that allow you to write smart contracts in I think Rust or other languages, and it will kind of like compile it back to bytecode, Ethereum bytecode. Um, yeah, but I'm not. I think they're still very. They're not really mature, or the adoption has not really picked up yet. Yeah. So, if smart contract, like I said, it has an address, you can send money to it, and when you're writing your smart contract, how do you handle that kind of situation where someone sends you money? Uh, Sorry, someone just. What about Python? No. Python. Python is not. I'm not. To the best of my knowledge, I don't think Python is used anywhere to write smart contracts on any blockchain. If I may be wrong, but um, I've not seen it anywhere. I think Rust. Yes, they use Rust in some places, but not Python. Okay, so how do you handle a situation where someone sends you money, right? Sends you smart contract money. So you can write functions that handle such situation. So if you notice this function is marked as table, meaning this function can handle um, a situation where money is sent to it. So usually there could be um, a default function that handles all table, any if anybody sends you money mistakenly without interacting with this function, there could be a fallback function that can handle that. But that does not happen in this particular case. Uh, so this is, then again, you could also withdraw money from smart contracts because um, unlike unlike a unlike an end user account, right? I can't withdraw money from someone's wallet. That's not possible. The person would have to send me money from his wallet, right? But you can withdraw money from the smart contract. So, okay, so I should zoom in my screen, okay? I can see very clear now. Yeah. So, you can withdraw, you can literally withdraw money from a smart contract. That's one thing you can do in a normal end user account. So if there's money in a smart contract and you have the right to withdraw it, then definitely you can withdraw the money from the smart contract. Then you can also deposit money to a smart contract. Um, yeah, so a smart contract is literally like I said, it's just like a person that is put on a blockchain and is able to do so many things. Then Solidity is also Turing complete, meaning you could solve any problem with it that you can do with other languages. So, um, so just an example of a smart contract. And just to touch on it too, um, so there are tools you use to, just like there are tools you use in building other programming languages, compiling and building other programming languages. So there are tools you use in building your smart contract. So once you've written your code in Solidity, right, you can then compile and deploy on the blockchain, either on the public blockchain or on the testnet. So the testnet is where you test your smart contracts first, right? So you test it, interact with it. Because remember, there are contracts that are not upgradable, meaning if you deploy it, you cannot modify it again, right? So for this kind of contract, you have to ensure you test it extensively and you test it properly before you deploy it on the blockchain. And one tool that allows you to do that is your testnet, right? So you have your Ethereum testnet. All blockchains do have a version, a smaller version of them that they call it testnet that allows you to test things that are not yet that you want to at least ensure works properly before you test it on the mainnet. So that's how I thought. Um, um, so there is hard hat. So hard hat is one of those tools that you could use for your deployments. So I'll just go to the website there. And so there's hard hat, there's Foundry. Uh, yeah, so hard hat and Foundry, I think that's two very popular popular tools for writing and deploying um, Solidity and writing smart contracts in general. Why better from the website? So I'm messaging this role. Okay, I would ensure I'll get. I don't know why I think that's it. Or if anyone knows the link for Foundry website, can just post it in the channel. So yeah, so HackHats is a kind of like a very popular tool for writing, debugging, and deploying smart contracts. It also comes with its own small testnet too. So it has a in-built testnet that allows you to debug your smart contract and ensure it works properly when you work for deployed. Then it allows you to write your testing, your smart contract testing TypeScript. So this particular example of my trade is actually managed by Hackers, like developing deployment and improvements managed by Hackers. So yeah. Then you could also have so one other thing, you could also have a multi-sig wallet, right? So a multi-sig wallet is one where you need you kind of like need the so for example, let's say when you deploy a smart contract, explain testnet and forcenet. Okay, forcenet. Yeah, honestly, I've not heard about forcenet before, but I've not heard about that honestly. So, but I know testnet is where it's like a smaller version of a blockchain where you do test your smart contract. But for forcenet, I think that's something new. If you could maybe drop any small description about forcenet, maybe something I've maybe interacted with, but maybe the name, I think the name was not what I thought it was or something like that. It's okay. So yeah, so you could have a look, see what. So when you deploy a smart contract, right? The person who deploys a smart contract has some privileges to that smart contract, right? So, for example, please excuse me, just give me a minute. Okay, so when you deploy smart contracts on a blockchain, you do have you do have some power over that blockchain, right? So, um, to, so if the blockchain is if the smart contract, for example, holds money, you could program the smart contract in a way that you can withdraw you can withdraw the money, right, from the smart contract when you want, right? But what if it's a situation where uh, someone steals your key, right? So if your key is stolen, so the person that has a key can withdraw all the money in that smart contract. So there are situations where you need you need the smart contract to request for multiple keys before you withdraw whatever money is held in that smart contract. So in that situation, you use a multi-sig wallet in that specific situation. So that's another feature of smart contracts function. So yeah, so that's for smart contracts. So so yeah, so if there's any question, I'll just pause for like 2 minutes. Thank you.
Hi. Hello. I have a question.
Sorry, please. Janet, please, can you drop your question on the chat box, or you wait, hang on, then you ask after the class. Thank you so much.
Okay. Okay. So I'm back. So I'll just continue. So smart contracts. Like I said, are like computer programs. Please forgive me. I don't know why the word small keeps coming in. They are not small. Smart contracts are not small. They could really be very large. And so, for example, the smart contract for, let's say, for um, Uniswap, for example, right? As in, as in, have so many lines of code, and though you split, so when your smart contract is very large, you have to split it into smaller contracts and make them call themselves and stuff like that. So they're not small enough. Okay, so then finally, we'll talk about EVM. So the I'll be speaking about. I'm talking about processing, right? Um, Computations, smart contracts, right? So what is in charge of processing all this, right? Is simply the EVM, and yeah, so the EVM manages states, right, for the Ethereum blockchain. So, like I said, financial transaction or moving money from one person to the other is just a side effect, if I may use that word, right, of what Ethereum is designed to do. You could, so like I said, Ethereum is more of a distributed state machine as opposed to a distributed ledger that Bitcoin is known for. So Bitcoin is a distributed ledger. So Bitcoin can handle just moving money from Mr. A to Mr. B, right? You need a ledger to record all those transactions and that movement. So that's what Bitcoin is. But Ethereum is actually a state machine. So a state machine is kind of like a processor, right? It's like a machine. Okay, how would I describe this now? Right? So a state belongs to something that can change, something that is dynamic. Like, for example, a human being has a state, right? There's sometimes where you could be sick, you could be hungry, you could be moody, like you could be happy, you could be so excited, right? So a human being has so many states, and those states, things have to happen to move you from one state to the other. So, for example, if you are if you have not eaten for a while, you would transition to the state of being hungry, right? Then, so not eating is an action. Then, when you eventually eat, right, you transition to the state of not being hungry. So actions do change states. So you need actions to change states for a human being and even for a computer. Okay, so someone is asking a question. What? Okay, someone's network is fluctuating and into another version of it. Okay, yeah. I think that would be fine. But hope I'm very audible. Hope everyone can hear me clearly. Please see mic check. If you can hear me clearly, just signify by typing yes chat section. Okay, so just like a human being needs to perform an action, or an action has to be performed on a human being to move that human being from a particular state to the other, right? That also applies to a machine too. So a machine could be in a particular state. Just for example, your phone could be off, and you have to turn on your phone to transition it to a state of being on. So a door could be locked. You'd have to open that door to transition it to a state of being open, right? So the same thing applies for the EVM. Okay, so someone is um, oh, okay, fine. Okay, so, yeah. So someone just said they could use Python in Ethereum development. Okay, that's cool. Never seen that anywhere, but that's what happens when you are in a big forum, as in things you've not seen, you get to hear about it. So, but I would also like to, um, is it kind of like is it used as part of a, okay, is it used as part of a framework, or does it play any role in the actual bytecode? Like bytecode, I would like to know if it's just something like TypeScript that is used to um, help with testing and stuff like that, or it's kind of like Rust that is actually compared down to bytecode into blockchains. Okay, so back to what I was saying. So um, yeah, so the same thing applies. Like states having a state, right, is a property of machines, right? Um, and or even human beings. And the Ethereum blockchain is, like I said, it's just like a huge, a, a distributed computer, right? And it has a state, and that state is um, is and every node that participates on the Ethereum blockchain, right? Every node that is a participant of the Ethereum network is responsible to a large extent for managing states. Not all, because some nodes are client nodes. They only consume states, right? And they are validator nodes that are the ones who actually manipulate states and process transaction. So the state is managed by every node that participates in the Ethereum network, right? So it's a global distributed state. So our our ETH balances, for example, is just a state, right, of the current state of our end user account. So if I have 0 ETH in my wallet address, right, that is the current uh, that's the current state of my sorry. Yeah, so if I have uh, 0 ETH um, in my my wallet address, then that's current state of my wallet address, and that state can change depending on if there is a transaction that credits my account, right? Uh, sorry, just give me 5 minutes.
Hello?
Yeah, yeah. Sorry about that. Yeah, so my dad, I just got called from my dad, so I had to tell someone to handle that. So Apology for breaking transmission. Yeah, so so like I was saying, the your current balance, right, in your wallet is a state, right? And for it to transition, so if you have zero ETH and for you to have, let's say, 10 ETH, right, an action has to take place. And what's that action? The action is the transaction, right? So the transaction has to happen that credits your wallet address with 10 ETH for the state of your accounts, right? To transition from 0 to 10 ETH, right? So that's just a simple. So that's how Ethereum sees transactions. It sees everything as a state, and transactions are actions that help to change states. And the EVM is the processor that does all that, that handles all that transition, all the state transition, right? So the EVM is what executes the transaction under the hood that changes states, that ensures, okay, someone sends you money and the money reflects in your wallet and stuff like that. That there's a smart contract. Then again, a smart contract. Remember, now tying this back to smart contract. Um, Remember I said a smart contract is a type of Ethereum account, right? So you have your wallet, your everyday wallet addresses, right? That's for the end user account, and you have your smart contract, which is also a type of Ethereum account. So and an Ethereum smart contract has an address, right? Um, so and what that means is you could um, and that now also means that your a smart contract has a state, and you could change the state of that smart contract by executing transactions against that smart contract, right? So just as you can execute transactions against a specific user's wallet, right, and transition that state from where it is currently to a new state. So um, anyway, though there's a notation, let me not go technical, there's a notation for kind of like describing it, but let me just go on with the literal meaning. So just like you can perform a transaction against a specific user wallet to transition its state in this sense is its balance, right? From point A to point B. You could also execute a transaction against a smart contract because a smart contract also has an address and can transition its state from let's say T1, right, to T prime, right? So that's all that transition and operation is handled by the EVM. Um, I think that takes care of my 2 points here. That one, an EVM is simply the computer that processes all the transactions on the Ethereum blockchain, like it's like the um, interpreter, right? And it's also handles state and storage management. Yeah, so for example, now so quickly uh, let me show an ERC 20. Let me see if I can. Uh, let's go to a dark card, right? Let's do dark card, and we will see an ERC 20 um, um, contract. Okay. Uh, so let's look for wrap. Let's look for the wrap material. Right? This guy will connect. Okay. So is this wrapped token, wrapped data? Okay. So wrapped data is a smart contract. So your cryptocurrencies, right, on the Ethereum blockchain are smart contracts, right? So smart contracts allow, and that's why, for example, you only have Bitcoin on Bitcoin network and nothing else. But on Ethereum, you have on Ethereum and other EVM compatible blockchains, right? The other blockchains that also have EVMs, they allow you have custom currencies that will call cryptocurrencies, custom tokens that will call cryptocurrencies. So wrapped ether is an example of that custom token. So it's just the wrapped version of the real ether. So the real ether is not a token. Sorry, it's not a coin. It's a token. And for example, you can't transfer it to another blockchain. So you cannot transfer Ethereum out of the Ethereum blockchain to another blockchain. But you can have a wrapped Ethereum, right? That is a smart contract that is one to one. Its value is one to one with Ethereum, and you can then move it to another blockchain. So that's the purpose of wrapped Ethereum. So then so let's now look at something. Let's look at the smart contract. So there's something I want to point out. So so you see so this works right. The other thing is just okay, these are just licenses. Okay, so you would see what we call balance, right? So you see your balance. So this so-called variable, right? It's a variable that holds balances, people's balances. So this is just a map. So it holds an address, right? Where your address is your wallet address and your wallet balance, right? So what happens is this smart contract holds the address and balance of every person that interacts with it, right? And it's able to do this because it has state. And you cannot have state if you don't have storage, right? So the Ethereum blockchain also stores state, right? So whatever state you interact with it stores it through. And so that's a very critical part of it, right? You can store information as well as process information. So that's like a full package. It's a network that's able to store and process information. So this picture here, right, is just a demonstration of that feature. So this wrap Ethereum can hold the balance of everybody who interacts with it. So you can get the balance of anybody by interacting with this smart contract live. There's no time for a demo. I would have loved to do a demo, but 1 hour is really, really, really small. But so that's the last point we also touch on, which is storage, right? That your smart contracts are able to kind of like store whatever information you process, and they can hold it. So you can always go back to retrieve information that has been stored in the smart contract via its storage features. So so this is deeper levels to this thing, right? But this is kind of like just a little explanation. Okay, zoom in your screen, please. Okay, this. Yes, so you can. So this is a link to the code for anybody who's interested. It's an Interscan. So Interscan is it's a tool that allows you kind of like look into Ethereum transactions, right? Artifacts that have been deployed blockchain. So like I said, so this feature here allows the smart contract, right, to store the balance of anybody that's interacted with it. Any person who has not interacted with it, right, or any address that has not interacted with this smart contract, try to get the balance of that address, you're going to get 0, right? Because that smart contract are very interactive. So this is what I'm saying to talk show. Then one last thing is when as we grow in this crypto space, you would have to interact with so many contracts, right? So I did mention I think in the second or first lecture that DeFi, like smart contracts, are the processing backbone that power Web3 and DeFi applications. So you write a front-end application, and the business logic is a smart contract on the Ethereum blockchain, right? So when you use an application like that, for example, let's go to this one. No, no, let's go to Calm. Calm is like my favorite DEX um, for swapping stable coins. I do use it for other currencies, though. Yes, so, but it's my favorite. But Uniswap is very, very popular. Okay, so now this is an application, and it's being powered by a smart contract on the blockchain, right? So it's very important every time to ensure you know what the smart contract is executing. So before you interact with any smart contract on the blockchain, right, it's very critical you know what it's doing, right? Yes, the interface is nice and all, right? But the moment you click the button, right, and you give it permission to do whatever that to do, and you don't know what the code that is behind it does, the application can literally steal all your money. So it's very critical to know what the code behind whatever DeFi platform you're using is doing. So one way to do that is very, very simple. So there is a contract here. So most times on the whatever DeFi platform, you would see a link to the contract, right? The contract or the address of the contract. So what we're going to do is to check the contract out on Interscan, and I'll point out something. Okay, so swap address, right? Okay, so this is the main address that does the swapping. Okay, so this is a contract. Like I said, smart contracts also have wallet addresses, just like your own wallet, right? So this is the address of this smart contract. And one thing you have to ensure now is, you see this green check here, right? This green check means this contract has been verified, meaning the publisher has uploaded the code and you can read what it does. So it's important to know what the contract does. It's very, very critical. And it's also important that you ensure that the code has been audited, that other people have gone through the code and they verify that the code does what it says it's doing, and it's not doing something secret underneath, right? Okay. So this is the code, right? So you can come here, read it. Though I know this code has been defined a lot, but you can still it hasn't been defined a lot. But you can still see it's easy to understand what's going on, right? You can still understand what's going on. So you can read it to confirm that the code does what it says it's doing, and that it's not going to steal your money behind the scenes. That's also very, very critical. And so I'm just showing you these are how people lose money sometimes when interacting with different platforms. And one other thing is when you try to perform a transaction, I have to go in here. So let me pretend I want to so let me pretend I want to transfer. I don't have a phone. So let me pretend I want to transfer small amount. I want to swap it small amounts of bits, right? This UI is not yeah, so let's say I want to transfer a small amount of bits, right, to where you see. Do I have this amount? I do. Let me try. Have I signed? Okay, let's see. So if I swap. Oh, wow. Okay, yeah, okay, so fine. So MetaMask would then kind of like, so this is something very, very critical. Do I know we're not there yet, but as we grow in your journey, you would have conversation with things like this. So let's move from MetaMask to so MetaMask would show you what is going to actually happen. So you can see there's a function type here, right? So MetaMask is telling you what function is going to be called on that smart contract, right? And it also show you the hex. So you can take this hex. So this is what these are the parameters, right? And this is what's the hex. So this contains even way more data. So you can copy the raw transaction data and you can inspect it to ensure that, because sometimes there are some DeFi platforms that the smart contract might be legit and looking fine, but when you click any button on their UI, they would modify. So let's say you want to swap 0.01 bits, right? So in their own code, they'll modify it to maybe take more than that from you. Yes, their smart contract is fine, but they'll put some like very tricky things on end to modify your transaction X before it gets processed on the blockchain. So yeah, when you use very popular platforms like this, you don't have such problems, right? But sometimes you might see a new DeFi platform you want to try out, right? So before you try it out, be sure that you verify that the contract has been verified. To ensure that the call being made is, you know what that function is doing on the smart contract, and that your hex, the parameters that is being sent, does not alter what you've imputed in the UI. So the UI can write, like I said, can write 0.01 ETH, right? But the code in the front end might change that, and when it gets executed, it's something else to do what you do expect. Yeah, so some people have lost money like that in DeFi, where they trusted a platform, and the platform was stealing little things from them, from the UI, right? But the smart contract was not doing anything wrong, but there were just some code in the UI logic that was stealing money from them. So these are things that you get to be very careful of as you try different DeFi protocols or DeFi applications in the future. So that's all for me. So thank you very much. I hope I've enjoyed the lecture series so far. I hope you have too. Very much. So if there are any questions, you can just push them up and try this. Thank you.
Thank you so much, Mr. Samuel. Please, does anyone have any question? If you feel free, you can drop it on the chat box, or you can unmute yourself and ask. I think we've answered those on the chat box already earlier. So if you have any pending question you would love clarity, or is there anything Mr. Samuel said that you need clarity with, please, we would like to answer them briefly before we end tonight's session. Thank you so much for joining. Okay, how can we get the videos of the previous class? Yes, Mr. Heritage, our videos are on our YouTube page, our YouTube channel, and we also have the links on our Discord channel. Please feel free to get them on our Discord. Okay. Yeah, okay. I'll be sharing the link to the Discord immediately. Thank you for asking. I'll be dropping it right now. Please, as I drop, if anyone has any question, please, you can drop it before I send in the link. Yes, thank you. I think I have it now. Yes. Here you have it, Mr. Heritage. Yes, that's our group link. You can do well to join. All our previous classes are there. Thank you so much. Please, does anyone have any other question? Yes, the slide. Once Mr. Samuel is done with his session, I will share the slide to the Discord server. I hope that's fine. Yeah. Once he's done, we would like you to follow through till the end. Once he's done with his sessions, we will make sure everyone has access to the slides and also the resources used. Thank you so much. So thank you everyone for joining this evening. Once again, we also have a great partnership with Thinkable Boat, where we have access to jobs now on our Discord server. So please feel free to join, to apply. If you have any issue applying, please feel free to drop your complaint on the general chat, and I'll be there faster than the speed of light to see how we can rescue and salvage the situation. Thank you all for joining us again. See you on the general chat, and we meet again on Wednesday, same time and same location. Thank you all. And once again, thank you, Mr. Samuel. Wishing you all a beautiful night rest. Good night, everyone. Bye-bye.
Yeah, thank you, everyone. Goodbye, everyone.